Right. See, quality of service, it is nothing but we make the router to get some extra knowledge of how to handle the traffic. Usually routers, they don't do anything extra other than routing. They do routing. That's what router can do. But routers don't have that knowledge to differentiate traffics, to say this is important than the other. To do that, routers are not that smart. Routers are not designed to be that smart to differentiate traffic. If you see traffic in network, we got various type of traffic. Some are very big and some are very small. Some are very important, some are very less important or no important. We got traffics of various importance, various size. For example, file transfer. If you are doing file transfer using FTP, they are going to consume really a lot of bandwidth and CPU than the voice traffic. The voice traffics are very tiny and they are also time sensitive. If voice don't go and reach the destination on time, then the quality of voice on the receiving side will be very poor quality. No one will like that poor quality voice. So voice need to be prioritized than the FTP traffic. But by default, routers don't understand the voice or FTP. For router, both are traffic. Both are bits. Whichever comes first to get processed, that will be processed first. Whichever comes first to get processed will be processed first. That is how the routers work. The default quality of service is FIFO, first in, first out. Whichever comes first will be processed first. For example, if a big FTP traffic comes, and in the end there is one voice traffic coming, which is going to be prioritized first. By default, the big FTP will be prioritized because that is the one which is coming in the front. After processing that big, like you want to board a flight, you are a single person, but there is one big family. I used to call this Gunda family. A big family of too many people, and behind them you are standing. Oh no. And that too, they don't speak good English. And these people who are in the boarding ticketing section, they stumble really a lot to get them the documents, passports. Now, you see, you stand at the back and there are around 6 to 8 members of a family who needs to get boarding pass in front of you and it is almost the gate is going to close. What will be your situation? How you will feel? Your gate is going to be closed in few minutes, but this Kunda family, they may take another 2 hours waiting time for their flight. You see, it is very difficult. If the airlines is good, what they would have done is they would have asked you, sir, where are you going? Okay, you're going to Dubai. Fine, your flight is going to leave. So better you go, friend. Let the Gunda family come at the back. So they won't allow the Gunda family to go to that ticketing section. They have to wait in the queue. Though I come late, but I'm only one person and my flight is about to go, I'll be served first. That is what quality of service is. That is what quality of service. It's not like you came second, what to do? Your flight, let it go. That's all. You cannot fly today. You buy another ticket. That's not a quality of service. That's very poor. That's very mean. Airlines. Very mean airlines will do that. So identifying the emergency and allowing the important traffic to be processed first is what quality of service. That is what we are trying to do on a router, or that is what we are trying to make a router to do for us. Quality of service is educating the router to differentiate the traffic based on the classification. The prioritization will be given. Based on the priority, importance will be given during the CPU process as well as during the routing process. Now, differentiated service or diffserve. What is diffserve? Opposite is intserve. RSVP traffic engineering is intserve. Intserve, integrated service. RSVP traffic engineering is integrated service, intserve. This one is diffserve. We are not asked here to learn about or talk about intserve. Here we are learning diffserve. Example for intserve is RSVP, Resource Reservation Protocol. But here we are not focusing on traffic engineering with RSVP. Here we are focusing on quality of service. Here we are not focusing on intserve. We are doing the opposite of intserve, which is called diffserve. What is differentiated service? Diffserve. See, the name itself very clearly says differentiated service, meaning not every router is going to have the same policy, same prioritization. It will vary from hop to hop. It will vary from hop to hop. It won't be same in all hops. That is what called as diffserve. See, in a network, the real network, you will see some portion of the network have got less bandwidth. Not everywhere you will have 10 gig link. There will be some portion of your network where you will have only 1 gig link or 100 meg link. Now, doing quality of service same on every router is not good. Why? Because not all routers are of same capacity. Not all the routers are connected with same capacity link. Neither the router is not same capacity of CPU and RAM, nor the bandwidth, which means we have to configure quality of service according to the capacity of the device, according to the location of the device. We call it as diffserve. We got different type and amount of traffic in different layers of your network. The traffic and access layer is not the same in distribution layer, not the same in core layer. So according to the device, your expectation to provide quality of service will vary. So we go to each router and configure what we want. In one router, you may give very good weightage for FTP traffic. Because via that router, you know very well that there is no voice traffic or multicast traffic going. But when you go to the distribution layer of your network, you find there not only data traffic, also voice traffics are going. So what you do now in this router, you give more importance to voice traffic less important to the other traffics, which is opposite to the configuration that you did in access layer. So we don't want end-to-end quality of service. We want hop-by-hop quality of service, which is what called as deep serve, differentiated service. Now, what is the word for end-to-end quality of service? In-serve, in-serve, in-serve. RSVP, I told you, it's a tunnel. It's a traffic engineering tunnel. It is end-to-end, which is in-serve. RSVP is a quality of service, which is providing end-to-end quality of service, meaning every router will treat that particular traffic in the same manner, same preference level. That is in-serve. That is the in-serve. Deep serve is, as I said, hop by hop. So now we are focusing on deep serve. In deep serve only we will have this policing, shaping. W red means weighted random early detection. Weighted random early detection. This Vivo cube is nothing but virtual. It is for multi-exit actually we use. What is it? Virtual output queuing. We'll talk about that when we go there. So we are going to see these 5 types. I just explained you what is diffser, the first one. Now what is policing is second one. Policing is when the amount of traffic exceeds the level of committed rate, those excess traffic will be dropped. That is what called as policing. Policing is monitoring whether the traffics are under the committed rate. Anything more than the committed rate, policing will drop. Why? Because we are going to have a shared network called internet. If one customer is sending too much of traffic more than what they have subscribed, what will happen to the other's bandwidth? Other customer will suffer. So to keep every customer happy, we have to do policing. Who have to do policing? Service provider. If service provider don't do policing, if service provider says, ஐயோ பாவம் போனா போது அனுப்பலாம். If ISP do that, finish. The other customer will not have enough bandwidth because you have given this customer's bandwidth to that customer. Now, that customer may be happy, but this customer is complaining now. So, policing is very, very strictly followed in ISP side. ISPs will do policing. What is that? When the incoming traffic is more than the committed rate, that excess traffics will get dropped. Before entering, it will get dropped, which is called policing. That is one very good quality of service. சும்மா கிடையாது இது இது ஒரு பெரிய quality of service. This is a very good quality of service. It helps to provide service to all customer in a justified way. It's not a simple thing. Policing is a very good quality of service. You just keep monitoring and say no excess. Sorry, drop. You see, that is what they do when you board a flight. They check, okay, 15 kg is allowed. Sorry, man, we cannot take more than 15. They don't allow because they know if everyone brings 15 kg, then the flight cargo hold will be comfortable. But when someone brings excess, there will be problem for other customer. Yeah. That is additional subscription you are paying. So here policing is whatever you subscribe, we allow you. If you have paid for excess baggage of 5 kg, don't worry, we'll allow you because you have paid. But we cannot give something free by saying Ayopav. Not possible. That is going to, then every customer will ask, then will you do Ayopav for everyone? Then problem. But when you fix a price for excess baggage, then they will know I should not take these items because these items are cheaper than the excess amount that I'm going to pay. Instead of taking this bedsheet and all, I can buy bedsheet wherever I go. Uh, no? So they will have some proper sense of packing. So policing is good. ISPs, all service provider will have policing. All service provider. I'm coming there. I'm coming there. But policing is the ISPs in the border, before accepting the traffic, they will check for the amount of traffic coming from the customer, whether they are within the limit or beyond the limit. When it is within the limit, they are welcomed. When it is excess, those excess bits will be dropped by no excess at all. Excess drop. That is policing. ISPs will always do policing. Shaping is different. Shaping is same like policing, but instead of dropping those excess traffic, it puts that excess traffic in a low priority queue so that it will be sent later. That is what, as you said, it will be slowed down. It will be kept in a buffer. You said that is what low priority queue. அப்புறம் போலாங்க நீங்க அப்புறம் போலாம் உட்காருங்க உட்காருங்க பரவாயில்ல உட்காரு. That is what shaping is. நீங்க பாட்டுக்கு அங்க போனீங்கன்னா அங்க போயிருந்தீங்கன்னா உங்களை வந்து எப்படியும் ரிஜெக்ட் பண்ண போறாங்க. எதுக்கு முந்தடிச்சு ஓடுறீங்க? கொஞ்சம் பொறுமையா போங்க, உங்களை அவங்க சேர்த்துப்பாங்க. That is shaping. See, shaping is what we will do for our traffic. Before sending the traffic out, we will see how much we are sending. We know I cannot send more than 100 meg because that is what I have subscribed. I have subscribed only 100 meg. So you check whether we are sending within the 100 meg limit. If something more tries to go out, we say slow down, slow down. Let 100 meg first go. That is what shaping is. Shaping prevents our packet getting dropped by the service provider. Shaping prevents our packet from getting dropped in the service provider side. Did you understand policing and shaping? Policing we won't do because it's our own traffic. If you drop, then you only need to resend it. Isn't it? Customer won't drop their own packet. If they drop, what will happen? They have to resend it. Isn't it? Yeah. So instead of dropping, customer will do what? They will slow down their traffic so that it won't get dropped by the policer on the ISP side. We shape it. We slow down the traffic. We slow down. That is what I call it as. We call it as shaping. Is it clear? Shaping? Not the user. No, 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 not the user. Not the user. See, the router have processed the packet. The router have processed the packet. Router, after checking routing table, it knows that I need to send the packet out on G00 interface. When it is about to send on that exit interface, QoS says, what is your size? And the data says, I am 200 meg. Sorry, let 100 meg go first. Why? Because the ISP is going to only accept 100 meg per second. So it only allows 100 meg per second out. As a result, the packet won't get dropped on the policer side. When you do shaping on the sending side, on the receiving side, policing cannot do anything. It will simply allow. When shaping is not done, ISP is going to drop your packets, which is excess, and whenever there is a drop, TCP packets will be resent again and again because there is no acknowledgement for the packet sent out. Customer is sent out. Who is dropping? ISP is dropping. So what will happen? The three-way handshake won't happen. TCP will not happen. So the customer will be keep on sending again, 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 again. Then more unnecessary traffic gets generated. To avoid all this, customer does what? Policing. அனுப்பவே அனுப்பாதப்பா, அனுப்பவே அனுப்பாது. எதுக்கு அனுப்பிச்சிட்டு அதை டிராப் ஆயிட்டு அப்புறமா அக்னாலஜ்மெண்ட் வரலன்னு அதை திருப்பி திருப்பி ஜென்ரேட் பண்ணி அனுப்பிட்டு எதுக்கு? அனுப்பும் போது பார்த்து அனுப்பிட்டோம்னா திருப்பி திருப்பி அனுப்ப வேண்டிய வேலை வராது. ஓகே, கேளுங்க கேளுங்க. கொஸ்டின்ஸ், யூ கேன் ஆஸ்க் கொஸ்டின்ஸ். கரெக்ட். எங்க ட்ராப் ஆயிரும்னா ஐஎஸ்பியில் ட்ராப் ஆகும். நம்பால் அனுப்பிச்சிருவான். நம்பர் அவுட்ரு 1 gig இருக்குது பேண்ட் வித்து, நம்பால் அனுப்பிச்சிருவான். Correct. ISP's agreed subscribe limit. Okay. Now there is a congestion. There is a congestion. How do we avoid congestion? How do we avoid congestion? Few years back in Delhi, they avoided congestion. You know how? Traffic congestion. How did they allow? How did they control? They said all the odd number vehicles will go on maybe 1, 3, and 5 days of the week. All even number will go on the even days, 2, 4, 6. That is one method of reducing the collusion, reducing the congestion. நெரிசலை தவிர்க்கிறதுக்கு அது ஒரு மெத்தட். But this is more smarter method. This one called WRED. This is also a congestion avoidance method, but this is not that cheap Delhi method. This is better method. What it is, we set weightage to different traffic. Say for example, we have voice traffic, FTP traffic, and some HTTP traffics, telnet traffics. So we identify the traffics and we say if voice is identified, we give high weightage. You see, we give weightage. We give weightage so that if congestion happens, we will not drop the most important traffic. We'll drop the less important traffic to avoid congestion. See, in Chennai, I know long year, like 20 years back, this rule came. What is the rule? After, I think, 7 o'clock in the morning and before 9 p.m. in the evening, no lorries should enter into the city. See, that was the rule on those days. I know that still the cities are following it. After 7 o'clock in the morning and before 9 p.m. in the evening, lorries should not enter into the city. Why? They want to avoid congestion. So, according to the government, they identified lorry as a less important traffic than car, bus, motorcycle. That is why they said we will not allow lorries during the peak hours like 7 to 9, morning 7 to evening 9. See, that is a weightage given to the lorry. What weightage? Less weightage. That is why it is getting dropped from 7 o'clock onwards. If you don't have weightage, then you will randomly drop whatever you see. The traffic police will stop whatever the vehicle they see. When the congestion happens, they will stop lorry, they will stop cycle, they will stop motorbike, they will stop everyone without a proper reason. They'll simply say, no man, congestion, so don't go. See, that is the weightage. See, when congestion happens, you have to drop some traffic to make the link no congestion. To make it free from congestion, there should be something done to drop some traffic to bring down the congestion. But which traffic to drop? That is depending on what weightage they got. High weightage traffics will never get dropped. Low weightage traffic will be dropped till the traffic comes to the normal flow, and then dropping will stop. This is what called as weighted random early detection. Why it is called early detection? You see, routers will not say congestion happened after 100% of bandwidth consumed. No. When the bandwidth utilization hits 70%, let's say, that depends on what you configure. This is how I configure. I'll say if 70% of bandwidth is already hit, if 70% is already consumed, now I'll configure drop 5% of traffic every second. 5% of traffic every second, so that won't go and reach 80, 90, 100%. Wait. Earlier it was random. Earlier it was randomly you detect the congestion. Randomly you drop the packet when you detect congestion earlier. Now we don't want to do randomly, we want to do according to the weight. That is why the name is weighted random early detection. Before WRED, it was only red, random early detection. Later came this WRED, weighted random early detection. So before the congestion happens, before it reaches 100% bandwidth utilization, before that you keep dropping when it reaches 70%. You keep dropping which traffic? The less important traffic. You keep dropping the less important traffics so that congestion will be within the limit of 70%. It won't hit 100%. So when a very important traffic comes, it will never suffer because it has got high weightage. It will never get dropped. It will go freely. Congestion cannot impact, slow down. Congestion cannot slow down the important traffics. Yeah. So that is W rate. Now what is this? Uh, mm, mm. VIP ticket. Okay. Now, no, that is good. Now, what is VOQ? VOQ is when you have single entry and multiple exit. I repeat, when you have single entry, see VOQ is virtual output queuing, meaning you got many output. See, single physical queue, single for input, no? Input queuing is a single physical queue. Traffic is entering in one interface, but it is trying to get out on multiple interfaces. Maybe a multicast example, multicast traffic. So it will be exiting on multiple interface. In this situation, what will happen if a congestion happens in one of the output interface? The input will be immediately stopped. If input is stopped, then all other output also will get stopped. You understand? That is what the normal procedure. Without VOQ, if one of the outgoing interface is congested, the traffic will be stopped for all outgoing interface. To avoid this, VOQ is configured so that for each outgoing, there will be a virtual queue created. So only the affected output interface will be stopped and other interface will not get impacted. See, the one output, wait, ensure that the congestion on one output does not prevent packet destined to the other output from being forwarded. All right, this is VOQ. Now I have put a use case example for everything and configuration also. This is available only in Nexus. This VOQ is not available in normal XR routers. And it's only available in 7000 series of Nexus. So I have put some example configurations for this weighted. This is according to the weightage. EF is a weightage. According to the weightage, we provide a threshold limit. You know? So use case for each topic with example configuration for shaping, for policing, what is diff serve, everything is given to you in this document. You give a quick reading. So this method, diff serve, policing, shaping, weighted random early detection, this is all for both switches and routers. When you do marking in .1 queue header, switches are going to see the marking, and according to the weightage in the marking, it is going to provide the preference. It is going to provide the priority. Whereas the same packet, when it goes to router will not read your layer 2 header QoS value. Router reads the TOS value of layer 3 header to decide what priority level that router should give. Packet is same, but in layer 2 .1 queue header, it is COS bit. Whereas in layer 3 IP header, it is TOS bit, TOS bit, type of service bit. Now, we also have 6-bit for QoS, which is called as differentiated service code point. If someone says, no, it is not 6-bit, it is 5-bit, that is also partially right. Actually speaking, 6-bit is reserved for DSCP, differentiated service code point. Differentiated service code point, DSCP. This is advanced layer 3 QoS. Normal layer 3 QoS is TOS bit. This is only 3-bit. This is actually 6-bit, but used is first 3-bit and then 2-bit. The last bit will be always 0. So some people will say it is only 5-bit. but it is actually 6-bit, including this. When you see only this 3-bit, we call it as QoS. When you see this 5-bit and take decision, then it is called as differentiated service code point.